Alright, so in this particular problem, it says the barge C is pulled by two tugboats, A and B, as shown in the diagram below. It says determine the magnitudes of the force F of B, or the force exerted by tugboat B, and the angle theta to develop a resultant force of 4,000 newtons directed along the x-axis. So essentially, here's the barge is being pulled by two tugboats, but essentially the statement is saying that the barge is going to move only in the forward direction, because it says here it produces a resultant force of 4,000 newtons along the x-axis. So essentially it's saying it is just moving straight to the right. It's not being pulled up or down. Okay, so the phrase resultant force suggests that that is the only force that is left over, okay, or the net force in this particular diagram. All right, so let's go and crack it out. Here's the F of B on the bottom, and here's the angle theta that's unknown. So let's go ahead and find F of B first. To find F of B first, the one thing you should notice right away is that the units are a little different here. It says the magnitude of the resultant force here is 4,000 newtons along the x-axis. However, in the diagram, the force applied by tugboat A is given as 2 kN. So K here is just kilonewtons. So you should definitely pay attention to units as you practice, okay? So I'm going to go ahead and convert 2 kN or 2 kilonewtons to newtons so that all my units are in units and newtons. So I'm going to set up the 2 kN here, and then the conversion factor between kN and newtons is for every 1 kN, there's 1,000 newtons. So the kN units will cancel out. So it essentially leaves you with just 2,000 newtons. Okay, so 2 times 1,000 is 2,000 newtons. And then I want to go ahead and identify all my components for FA and FB in no particular order. I'm just going to do FAY real quick here on the diagram. So FAY is pointing up because the vector, the force vector here for tugboat A is up and right. So I'm going to do FAY is pointing up. And then I'm going to go ahead and draw a component for FAX pointing to the right. All right. And then for tugboat B, it is being pulled down and right. So the component in the Y direction must be pointing down. So that is FBY pointing down. And then as you can see, the F of B is pointing down and right. I've already taken care of the downward component. So therefore the next component that's going to come up here is FBX, which is also pointing right. So right away, you notice there are two components pointing right. FAX is pointing right. FBX is also pointing right. However, in the Y direction, though, you have FAY pointing up, but FBY pointing down. Again, this is the top view problem, is the bird's eye view problem. So your coordinate system is in a two-dimensional plane. Okay. So I'm going to set up my X and Y information here. This is just to help you organize your information. Right away, I can attack the X direction by saying the net force in the X direction is FAX plus FBX, because FAX on the screen here is pointing to the right. FBX is also pointing to the right. So I'm just going to add, okay? But I don't know what FAX is, okay? I don't know what FAX is, so I got to go find FAX. The problem gives you enough information to find FAX. The angle for FA relative to the x-axis is 30 degrees. Hopefully my drawing here isn't overlapping it too much. You can tell the angle here is given as 30 degrees, okay? So therefore, I can say cosine of 30 is adjacent. Adjacent would be FAX, because that's the adjacent leg to the angle 30, over hypotenuse. Hypotenuse in this case would be the vector A itself, because the vector A is now your hypotenuse, aka the diagonal. To find FAX, we multiply both sides by FA. Therefore, the FA went on the left side by multiplying. And FA is given as 2,000 newtons. This is where you got to be careful. You know, you don't want to plug in 2 without paying attention that this is 2 kN. So make sure you convert units before you start plugging in your calculator work. Here's 2,000 newtons. Here's cosine of 30. And if you plug 2,000 times cosine of 30, you should get about 1,732 newtons. Here I'm going to do some rounding because the numbers are pretty big, so I'm just going to keep it in the thousands. All right, so FAX I already know is 1,732 newtons. So here, back to my chart. Well, I know it says the net force for the barge is in the X direction, and that has the magnitude of 4,000. So if you read these types of problems and you don't understand what's given to you, you might cause yourself a lot of confusion. Right? It says the resultant force of 4,000 Newton is directed along the x-axis. So therefore, I know the net force along the x-axis is just 4,000 newtons. But I know FAX now, which I just calculated by simply using geometry. Cosine of the angle 30 is going to give me 1,732. As you can see here in the statement, the only thing that's left as unknown is FBX. So to find FBX, I can simply subtract 1,732 newtons on both sides. Therefore, I'm just going to move the 1,732 on the other side of the equal sign, which changes the sign. And if you do 4,000 minus 1,732 newtons, you should get a value of about 2268. Okay. So I know FBX is 2,268 newtons. Well, that helps me find FBX. But in order to find FB, I need either an angle or the other leg. So essentially, you're just trying to solve for a triangle. But to solve for a triangle, you need enough information. You need at least two legs or a leg and an angle. Otherwise, it becomes impossible. But here, I'm just going to solve for the two legs. I just found FBX was just this component horizontally pointing to the right. It gives me enough information to find FBY because if I set up my net force in the y direction, here on the right side in blue, well, net force in the y direction is simply FAY because FAY is pointing up. I'm going to subtract it from FBY. So here you notice here I highlighted my negative sign here. I'm going to go ahead and state that FBY is negative. So I'm adding a negative, but it's like subtracting on positive. So I like to take care of my negative sign right away. So in the diagram earlier, if you kept up, I drew my FBY component pointing down. Well, pointing down would be negative along the y-axis. So right away, I want to go ahead and say that FBY is negative. So keep in mind that I've already introduced my negative sign as usual in my work, okay? Here, the net force in the y direction is 0. Well, why is it 0? Well, the problem states that the barge is only moving rightward because it says the net force, aka the resultant force, is 4,000 newtons along the x-axis, suggesting that the net force in the y direction must be 0. So that's where the 0 comes from. So here I have FAY pointing up. I'm going to subtract that from FBY pointing down. FAY I can find using the same strategy with cosine of 30, but here I'm going to use sine of 30. FAY, watch where I'm circling on the cursor. FAY is my opposite for the angle 30. Well, if it's opposite, you have to use sine because in mathematics, sine of the angle is opposite over hypotenuse. So here my opposite is FAY, my hypotenuse is FA because that's the vector itself, which is the diagonal, aka the hypotenuse in these types of diagram. To solve for FAY, I'll multiply both sides by FA. And then if you plug in FA as 2,000, because it's given in the diagram as 2 kilonewtons, which is 2,000 newtons, we converted earlier up here. If you do that, 2,000 times sine of 30. Sine of 30 is a half. Half of 2,000 is 1,000. So therefore, FAY is 1,000. Well, now that I know what FAY is, I can go back to my chart. Well, net force in the y direction is 0 because the barge is moving straight to the right of the screen. It's not going up or down. And I just found FAY. Okay. So FAY I just found as positive 1,000 because that FAY is pointing upward. So the only thing that's left unknown here in this statement is FBY. So therefore, I'm just going to solve for FBY by moving the negative FBY to the other side. So it tells me FBY has a magnitude of 1,000. Keep in mind that I already tell you that FBY is negative. So therefore, I want to translate this information in the chart into just a triangle. Well, the red arrow that just came up is the net force in the x direction. Okay, and that is for the vector B. So you notice here it says FBX is 2,268, and it's positive because in this diagram, tugboat B is pulling in the southeast direction, aka to the right and down. So FBX must be to the right, and then FBY though must be pointing down. So even though I found the magnitude of FBY to be 1,000, this is where you don't want to draw the vector up, okay, because that would be a misconception. I already told you earlier that FBY is negative, and by common sense, the diagram tells you it is also negative. So even though you found the magnitude, you have to make sure you draw this particular component correctly. So here in my work, this component is pointing down because, well, FBY, using common sense and referring to the diagram, has to be pointing downward. Okay, so this is negative 1,000. So therefore, knowing the two legs, I can find FB by applying Pythagorean theorem. Right? Essentially, you have a right triangle. You have the two legs. So it would be a squared plus b squared is equal to c squared. But instead of calling A, B, and C, in physics, we just use physics terminology. So we can say FB squared equals FBX squared plus FBY squared. Well, we know what FBX is, 2,268. We're going to square that. And then FBY here, just for formality, I put it in the negative sign, but it's in parentheses. So squaring a negative number is actually going to give you a positive number. So therefore, if you do this correctly on your calculator, you should get this is a massive number. What is this? 6,143,824 Newton square. It's just a massive number. But to find f of b, though, we got to square root the whole entire left and right side. So therefore, square rooting the right side of 6,143,824 would give us a value of 2,479 newtons. So that is our f of b. Okay, so tugboat B needs to pull with 2,479 newtons in order to keep the barge moving straight. All right. Now, the other part of the question asks you to find the angle. Watch what I'm circling. All right, it says calculate the magnitudes of f of b, which I've already done, and then it says and the angle to develop a resultant force. So essentially, what is this angle between the horizontal and the vertical? All right. Well, to do this, I like to use tangent. At this point, you already know what f of b is, so you have all three legs. You can use cosine, sine, or tangent. I'm just going to use tangent because in my screen here, I already have the fby, which is my opposite, fbx, which is my adjacent. So to find this green angle, I can do tangent. Tangent by definition is opposite, which is fby, which is negative 1,000, which I put on the top, over adjacent, and my adjacent in this case would be 2,268, which is on the bottom. So if I do that, I'll get a negative 23.8 degrees. Okay, so the proper way to say this would be, 23.8 degrees below the positive x-axis. Or if you want, you can say negative 23.8 because if you measure from the x-axis, which is assumed to be 0 degrees, and you go backward and you go clockwise, in math, that would be negative 23.8 degrees. So that'd be the answer. All right. Other than that, I hope that helps. Stay nerdy. Don't be whack.